Okay. So firstly, we are going to take up the topic for physics. And in physics, I'm going to talk about force, right? This is the second chapter of your physics. Basically, force is defined as a push or a pull given to an object, right? Force is
Yeah.
basically defined as a push or a pull which is applied to an object. Fine.
Yeah.
Now, this push or pull can lead to state change. What it means? It means if the object is at rest and I'm going to apply force on that object, what will happen?
Hello.
It will, hello?
Ma'am, can you minimize this extra screen?
Actually, it is not happening.
You will select the board now where you are writing. It's there at the bottom. Yeah, it's gone. And
Oh,
please hide this one. Meet.google.com sharing your screen. There is an option for stop sharing.
hide, yeah.
Hide.
Fine.
Yeah, thank you.
Okay. So coming back to the topic, I was telling about the force. Force is basically defined as a push or a pull. Whenever a push or a pull is applied to an object, it will lead to the state change. That state change can bring a stationary object to be in motion or an object in motion to come at rest. Fine. So
Yeah.
state change can bring two changes. It can bring a moving object to come at rest. And second thing that can be done is a rest object to be in motion, right? Now, as we know, speed, velocity can have the SI unit as. Can you tell me, Lakshita, what is the SI unit of speed and velocity?
Um, Meter per second
Right, it is meter per second.
and
Yes.
Newton.
Yeah, definitely. As we have speed and velocity SI unit as meter per second, similar way we have the unit for force as Newton, right?
Yeah.
Indicated by capital N. Fine. Now this force can be of two types. One is called as balanced force and second one is called as unbalanced force. How we are going to differentiate between the two? So I'm taking the example which is given in your NCRT book.
Yeah.
If I consider a block of wood kept on a table, right? This is a box, or you can say a block of wood. It is kept on a table. And if I try to pull this block towards the left and try to pull this box towards the right side with equal amount of force, right? For example, if I apply 5 Newton of force pulling this box towards the left side and 5 Newton of force pulling it to the right side, then can you tell me the result of this box? Would it be able to move or not?
Um, if Can you repeat it?
Yeah, definitely. See, you imagine a situation, two persons are standing. One is on left and second one is on right. Fine.
Hmm.
This left person is applying 5 Newton of force pulling towards the left. He's trying to pull this box towards the left side by applying force of 5 Newton. And similarly, this right person is also trying to pull this box towards himself, applying the same amount of force, which is of 5 Newton. Would anything happen to this box?
No, because both of them are pulling it towards each other,
Right.
so it's not gonna move to either. of the person.
Lakshita, see, you are slightly right, but you are making one mistake. Both of them are trying to move this box towards themselves. This is
Yeah, and
fine.
it's the same amount of pressure
Very good.
exerted,
Yeah,
right?
this is the catch point because they are applying the same amount of force,
Yeah,
trying to pull this box towards themselves with the same amount of force. That is why this box is not going to move,
yeah,
right? This box is not going to move. So you can see that if forces are of equal amount, then that is called as balanced force.
okay.
That is called as balanced force. So these two persons are applying force, but being equal in amount, nothing will happen to this block. Is the
Yeah,
situation fine? Clear?
yeah,
Right. Now taking the second example, same example. If I say this person is little stronger than this person, he's weak, but he's strong, right? And if he's strong, he's definitely going to apply more amount of force. Now if I say the left person is applying only 5 newton of force and the right person is applying 15 newton of force, now can you tell me where the block is going to move?
the stronger person, right side.
Right side, yes.
Yeah,
Definitely, the amount of force is more because the person is stronger. So definitely this block is going to move towards the right side. And since you can see that the amount of forces are different, that is why we called it to be unbalanced force. Is it clear?
yeah, ma'am.
Any questions?
No, ma'am.
Fine. Now, after that, we have laws of motion. We have three laws of motion. I will just brief up the first law, which is also called as law of inertia, right?
Yeah.
Now, should I tell you the statement or you know it?
Uh,
Let me remind you.
yeah.
Okay? Now, statement of first law, or we can say that the law of inertia is an object remains in a state of rest or of uniform motion in a straight line unless compelled by an external force, right? So this is the statement. Knowing the statement is also very important because these can come directly in statement forms that they can ask you state law of inertia for 2 marks. So this is learning these statements are also important. That is why I have written it. According
Mm.
to the statement, it says an object remains in state of rest or of uniform motion in a straight line unless compelled by an external force. That means every object that we have would try to remain in its state, whatever it is. Either it is stationary or it is moving. See, if it is moving, then it will remain in motion with the same speed until and unless we are going to compel it through an external force. For example, I'm giving you an example. If you are driving a bicycle,
Yeah.
ठीक है? If you are driving a bicycle, say whatever speed you are driving it, if you are not going to pedal it, will it remain in that motion?
Yeah.
Would that remain in motion if you are not pedaling your
Oh, if
bicycle?
you're not doing anything, there's no motion, but if you're pedaling it, there is
No,
motion.
see, I'm saying if you are driving a bicycle, say at 5 kilometer per hour, with a speed of 5 kilometer per hour, you are driving your bicycle, then
Mm.
would it be able to change its speed if you are not pedaling?
Uh, First you're pedaling, right?
Huh.
Yeah, if you stop pedaling, it will like change.
Yeah. So
Because
my point is, if we are going to apply force externally, right? If we are going to apply force externally, see, if you are driving your bicycle at a speed, particular speed, then it will remain in that speed only if you are not applying any force by not applying pedal. But if you apply pedal, then you are going to increase your speed. If you are going to pedal your bicycle, then you will increase your speed. So this speed, this tendency of you to be driving your bicycle is governed by this force, how much force you are applying.
yeah,
Is it clear?
yeah, ma'am.
If you are sitting, see, if you are sitting and you are not applying any force to your body to make it move, would your body move?
Can you repeat it?
Yes, I'm saying if you are sitting
Yeah.
and you are not applying any force to your body, will it be moving?
No.
Yeah. So, got my point?
Yeah.
Fine. Now, if again, this can be illustrated by an activity. If I take a glass, if I take a glass and keep a
Hmm.
cardboard over it, and place a coin, right? I have
Hmm.
taken an empty glass, put it a cardboard on it and a coin, and if I try to flick this cardboard, if I just try to flick this cardboard like this, so what would happen?
The cardboard would fall.
Yeah, the cardboard will flick to this other side, and what will happen to this coin?
The coin will go with it
Where? The coin will
to
go?
the right side.
No, I'm not applying any force to this coin. This
So it
coin
will
is
go
at
in
the
the
state of
water.
rest. It will go into glass.
Yeah.
It will go into glass. See, I'm applying force on this cardboard, not on coin. So what will happen? This cardboard will be flicked off. It will be taken away, but I'm not applying any force to this coin. So it will fall down in the glass. Got
Yeah.
my point?
Yeah.
Is it clear?
Yeah, ma'am.
Any doubts?
No, ma'am.
Fine. Okay. All right. So we can say that inertia is a natural tendency. It is a natural tendency of an object to remain at rest or in motion. Fine.
Yeah.
Clear? Am I clear to you?
Yeah, ma'am.
Okay. So this was about the physics part. If you want to note something or you can ask something, you can. Then we will switch to next subject, which is chemistry.
Yeah, ma'am, I've written the top part. Can you go down?
Yeah.
Little more down. Yeah.
Is it fine, Lakshita?
Yeah, ma'am.
Okay. Shall we change the topic?
Yeah.
Okay. So now we are going to take up the topic of chemistry, and we are going to discuss about the models of atom. The first one majorly.
Yeah.
Do you have
Um,
any pre-idea about models of atom?
I don't have that chapter.
Mm, why?
I don't know. I have in chemistry, I have matter in our surroundings is matter around us pure, and atoms and molecules, and structure of an atom.
Yeah, that structure of atom is having the models of atom. It is a part of that chapter, chapter 4.
Oh, fine, fine.
Okay,
Mm.
fine. So, if I ask you what is atom, can you describe it in simpler words?
Atom has it's the smallest. I mean, like, oh God, that's said.
See, atom is described as the
Oh yes, smallest particle.
smallest particle of matter,
Yeah,
right? So this is the catch point for writing the definition of atom. Atom is described as the smallest particle of any matter. Fine.
yeah.
Now, according to the theories, atom was described by Dalton, scientist Dalton, and we have a theory of Dalton also in which he said many points about atom. According to the Dalton's theory of atom, the most important point is that he said atom are the tiny particles,
Isn't
tiny, sorry,
no? There's particles like inside atom or something, right?
yeah, they are the tiny particles which are present in any matter. Fine,
Yeah.
particles which are present in any matter. Now, these particles are indivisible. That means Dalton said that atom is that smallest particle or tiny particle, you can say, which is indivisible, which cannot be divided further. According to Dalton, it was said. Fine. But
Yeah.
later on, with the experiments of other scientists, it was found that atom can have subatomic particles. That means other
Mm.
scientists said that atoms are divisible and atoms have subatomic particles. Can you name any if you know?
Subatomic. This proton,
Yeah, right.
neutron.
Yes, you know it. Very good.
Yeah, proton, neutron, and I forgot.
Electron it
Yeah,
is.
yeah,
Fine. So Dalton said that atom is the tiny particle which is not further divisible, but many scientists conducted experiments and they found out that atoms are divisible and they are having further subatomic particles which are proton, electron, and neutron.
yeah.
Right? Now, Dalton, let me tell you the scientist who discovered them first. Proton was discovered by scientist E. Goldstein. Electron was discovered by scientist J. J. Thomson.
Mm.
And neutron were discovered by, can you tell me?
What?
Neutron was discovered by scientist Bohr.
Mm.
Bohr. Fine. So
Yeah,
these are the names of scientists that discovered these subatomic particles. Fine.
yeah,
Now, when the story comes in that atoms are having subatomic particles, so every scientist was keen to know what is their arrangement in a particular atom, how protons, electrons, and neutrons are arranged in particular atom. This becomes the question of curiosity, and for those curious questions, many scientists tried various experiments to come up with the models of atom. So, first scientist that gave the theory about this atom was scientist J. J. Thomson, who gave us the model called as plum pudding model. or we also call it as watermelon model. See, till this scientist discovery, it was only two particles we are concerned with. They are proton and electron. These were the two initial subatomic particles that were discovered. One was proton and second one was electron. And scientists were trying to know their arrangement. So J.J. Thomson was the one who came up with a theory giving the model as plum pudding or the watermelon model. See, he said, if you know, the watermelon is having two parts. One is the red part, red colored part. The whole watermelon is red in color from inside,
Hmm.
right? And we
Yeah.
have black colored seeds in it.
Yeah.
We have black colored seeds in it, but these seeds are embedded randomly and they can be present anywhere on this red colored sphere in the watermelon. Fine. So he compared the atom to be a watermelon. How? He said this red colored portion that we have in watermelon is called as proton, right? He said this
Yeah.
red colored portion of this watermelon to be the proton part of atom, and these black colored seeds which are embedded in the structure, they are the electrons. They are the electrons. Fine.
Yeah.
So he said the red part is your proton part of an atom, and the electrons are like seeds which are embedded in this watermelon. Right? He also said one important thing, that number of protons or the magnitude of this proton is equal to that of electrons. See, we represent further in further studies when I would be going deep into these topics. So I would be telling you that proton is represented by P plus. These are the sign conventions that we use, and electron is represented by E minus. Electrons are negatively charged particles and protons are positively charged particles. So according to J.J. Thomson, he said that the amount of positive charge that we have in an atom is equal to that of electrons. So he said, if I take a random example, he said, if we have 10 proton amount in a particular atom, so that 10 proton amount is going to be equal to the number of electrons. That means if we have 10 protons in an atom, we are going to have 10 electrons in the same atom.
Hmm.
Is it clear? He
Yeah.
said if we have 10 number of protons in an atom, then we are going to have 10 number of electrons in that same atom. So
Okay.
according to it, see, 10 positive charge is equal to 10 negative charge. So what will be the overall charge to that atom?
10,
10 positive unit charge we have and 10 negative unit charge we have. So what will be the overall charge?
20,
No.
or 0.
And yeah, it is going to be 0.
Okay.
Overall charge is going to be 0, right? Why? Because
Why?
you can see that it is having 10 positive charge and it is having 10 negative charge. So that is why I'm asking you what will be the overall charge on that atom. So it is going to be 0, right? So yahan se we got another point. He said that atoms are electrically neutral. He said a very, very important point, that atoms are electrically neutral. Later on, further scientists come up with their theories. Second one was Rutherford, and after that we have Bohr model. The most acceptable model till date is the Bohr one. But J.J. Thomson gave us a very important conclusion about his model, which is that atoms are electrically